Hello, guys. We are in science today, and Miss Wolf made an oopsie. I forgot last week we were supposed to finish up Earth systems before we moved on to resources. So we're just going to do a flip-flop. We're going to go back to our Earth systems. Specifically, we're doing things in the atmosphere. So we're going to do global winds today, and tomorrow we're going to be working on climate. So we're going to go ahead. We're going to read our article first. So we're reading Global Winds and Jetstream. Wind is constantly occurring in different layers of our atmosphere. So remember, we have several different layers of our atmosphere. We exist in the troposphere, which is where all of our weather occurs. We want to remember what wind is caused by. Wind is caused by air of different temperatures and densities moving from areas of high pressure to areas of low pressure. So on your student version of this, guys, make sure that you are highlighting the definitions that I am highlighting with. Global winds. So wind is just wind in general, right? This can be in a specific area. It could be over a large area, right? We have wind occasionally near us where we live at home, at school. But then there's something called global winds. So global winds blow steadily across the earth in long paths that almost cover the entire surface and steer weather in certain directions, right? So our earth has global patterns of wind which constantly flow, right? And remember, we learned that wind flows from areas of high pressure or cool air sinking closer to the earth's surface to areas of low pressure, which is where we have warm air rising into the atmosphere. So remember, when we talk about why air sinks and rises, warm air rises because as it gets closer to the Earth's surface, the surface of the Earth retains heat that it gains from the sun, right? And so that heats up the air. And remember, when we're talking about air, the density of the air has to do with how close the particles are. So as the air gets warmer, the particles separate, so it becomes, in effect, lighter. So as the particles separate, because they're moving at a faster speed, they raise up into the atmosphere. But what that does is it creates a vacuum. That air is now moving upwards. Something needs to go to fill its place. So cool air has been sitting in the upper atmosphere, right? And that cool air, what happens to it is it starts to get colder because it's further away from the Earth's surface. And it now is getting chilly, right? So it's starting to cool down. Think about like if you've ever gone up a mountain, or higher elevations tend to be cooler because you're further away from the surface of the planet. And so as that air gets cooler, it starts to sink back down. And what happens is as that air sinks down, where air is raising in another section of a surface, that cool air now fills its place, right? So you have this circular feature. Then as that air is moving across the Earth's surface, it starts to heat up and it raises up back into the atmosphere. And you have this circular pattern, right? So global winds are essentially that same idea, but on a global scale, right? Think about areas that are very warm on our planet versus areas that are very cold on our planet. Well, our cold areas are the poles, the North and South Pole, and our warm area is the equator, right? Our equator is the hottest part on the planet. So that's where a lot of the warm air is. That warm air wants to go towards the cooler areas on our planet, which would be north and south, right? So it starts warming up at the equator, and then it starts to separate and head in the direction of the North and the South Pole. So that's exactly what we're going to read next. These patterns begin at the equator where the sun's rays are the strongest. Here, air is heated, becoming less dense, and it moves north as well as south from the equator. As it cools, it becomes more dense. Some of the air sinks back towards the equator, causing a convection cycle of air. The warm and steady winds that move towards the equator are called the trade winds. So if we were to break up our latitude lines, right, this happens between 0 and 30 degrees north and south of the equator on those latitude lines. So essentially, you can think that if the planet was sitting still and not moving at all, right, the Earth wasn't rotating on its axis, and we still had this warm air at the equator and cool air at the poles, that air is going to move in a straight line north and in a straight line south. Some of it, as it cools, though, is going to get sinking down, and it's going to remain kind of in its own little area. But some of it's going to continue moving north and south. But the problem with that is that our planet is actually moving, right? It's rotating on its axis. So although the trade winds move north and south, they don't move directly up and down. So they don't travel in a straight line. And the reason that this is because the movement of the wind is curved because of the Coriolis effect. Because our Earth is constantly spinning, the winds that move directly north and south actually end up curving just a little bit. So because of this, we actually have two other areas of wind patterns that we have on our surface. So the further you get from the equator, you have now 30 to 60 degrees north and south. We call these the prevailing westerly winds. So these winds come from the west and move east. And they're responsible for a lot of the weather that we have in the United States, right? So this is just the next cycle of air moving north and south. Then we have polar easterlies. So these occur from 60 degrees latitude to the tops and the bottoms of the planet. And this is just cool air that spreads and sinks over the surface of the north and south poles and flows away from the pole, turning towards the west by the Coriolis effect. So the air at the poles is trying to head to my brain is so dead, guys. I apologize. The air at the poles is trying to move towards the equator, just like the air at the equator is trying to move towards the poles. So I'm going to go ahead and we're going to fill in some definitions. So we want to make sure that we are highlighting our definition for trade wind, which is warm and steady winds that move towards the equator. Next, we have the Coriolis effect, which is the movement of wind due to the Earth constantly spinning. And you'll see. So Coriolis effect. Because the Earth is constantly spinning, it causes the winds that move directly north and south to curve just a bit. We're going to have a video of this on Thursday you guys can watch that kind of explains this a little bit better. But for now, this is the general idea. Between 30 and 60 degrees are the prevailing westerlies, and the polar easterlies occur at 60 degrees latitude. So now that we've gone over this, we're going to talk about a special type of global wind. So above the Earth's surface, there's a global high-altitude wind in the troposphere layer of the atmosphere called the jet stream. So this is above most of the weather, but not all of the weather in our troposphere, in our atmosphere that we kind of exist in. The jet stream, actually, here you go. So this is a high global altitude wind in the troposphere layer. It flows at over 200 miles per hour from west to east in one or more bands across the globe. The jet stream is caused by two air masses in the troposphere that have extremely different temperatures. The greater the temperature difference between the air masses, the faster the wind blows. So basically, because we have sections on our Earth that our Earth is heated unevenly, and because we have these sections on the planet that are so far apart, and we have these massive differences in the temperature, it actually creates a lot of wind in that upper atmosphere, essentially, right? So we see this a lot going from west to east, right? So I'm trying to find where we left off. The greater the temperature difference in the air masses, the faster the wind blows. The jet stream can steer weather across the country. It can give a boost to airplanes traveling from west to east, right? So it might take you 5 hours to get from Washington to Massachusetts because you have that jet stream that you can kind of just get right into, and that's going to cut down some time. But when you're going in the opposite direction, it's going to add an extra hour because you don't have that wind to help you move at a faster speed. So let's go ahead on to our questions. All right, so what is wind? Air movement caused by air of different temperatures and densities moving across areas of high pressure to low pressure. And what I'm actually going to do is I'm going to draw us a picture to help us remind that. So here I have my low pressure. I don't know why I'm doing this with my mouse when I have my little doodle. Okay. So remember, in low pressure, we have warm air goes up into the atmosphere and spreads away, right? Now, as it cools down, it sinks, and now we have a high pressure. That was a really bad arrow, guys. And then this just repeats, right? We talked about this. So it's just this continual cycle of high flowing into low pressure on the surface of the earth. So this is kind of our little guide to help us remember what that looks like. There you go. So now oh my goodness, my keyboard does not want to function for some reason. There we go. Oh my goodness, here we go. All right, so what causes wind? Air flows from high pressure areas of cool air to low pressure areas of warm air, right? And it cools, as the air warms, it cools within the atmosphere, right? So it's that changes of temperature and density that cause wind. So now we have the Coriolis effect, and here's a picture to help us visualize the Coriolis effect. So first, let's see what is the Coriolis effect. Our air moves from north to south, but it also curves due to Earth's rotation. So I am going to grab a drawing tool. Okay. So if this is the Earth, that's a really bad circle, but bear with me, right? And we have our equator here. Okay. If there was no if there was no rotation to the planet, warm air would go north towards the poles and south towards the pole, and cool air would go from the poles. I did these in the wrong direction, guys. I'm sorry. So warm air goes from the equator to the poles, and cool air goes from the poles. Oh, Miss Wolf. To the equator, right? That's our cycle. We know this. We've learned about this high to low pressure, right? Or low to high pressure. Now, what happens is because the Earth is spinning, it might move in a straight line, but the surface of the Earth is in a different area. So it looks like, or it feels like to us, that the wind patterns are actually curving. So you can see here on my picture that I have drawn for you all of the different patterns of the wind. So the wind kind of goes at the poles, it kind of flows from east to west. in this middle area between 30 and 60 degrees latitude, we go from west to east. And then you can see here at my equator, we kind of have this band that goes right towards the equator. So we have the polar. So let's scroll up. So we have polar easterlies. So we need to fill that in. Boop, boop, boop. All right, so let's grab another text box. And we have prevailing westerlies. And in the center of this all, we have the trade winds. So the reason actually we call these the trade winds is because this is what boats would use to get from Europe and Africa over to the Americas, the New World, right? So this is what they would use. They would essentially sail down and use this to speed up their trip a little bit, right? And you can see here, kind of at 30 degrees, you have, and down here at 30 degrees as well, you have air moving away from each other, right? They're not like here, you could see they're moving towards each other. This is what sometimes was called the doldrums, because this is where you didn't have as much wind to move you. So if you were using a boat with a sail, you didn't always have wind to fill those sails, which means you were kind of drifting if you didn't have like oars to help you out. So the jet stream. A global high wind in the troposphere that flows west to east, forming a pattern or band. So I'm going to draw you a little earth again. There is my earth. So I'm going to very poorly, guys. This is the United States, we'll say. You got South America down here. This is Europe, Africa. This is a very poor representation of our planet, but here's what I'm trying to show you. The jet stream usually goes like this in that direction. Now, sometimes it's curly cute. It'll kind of go up like that, right? Sometimes the jet stream dips lower and it falls into warmer waters by the equator. It really depends on weather, on the upper atmosphere conditions that cause weather, right? But basically, it's this band of air that moves kind of in this way, right? It might deviate. You might have it dip down here, right? Or it might go up like this. I've definitely seen it in both ways before. Pardon, Bruce. He heard a staff member text me and freaked out. So here's what you guys are going to do today. I want you guys to think about it, okay? And then you're going to write about it. So what are global winds and how do they affect Earth? So on your own, I want you to answer this question, explaining your answer using information from the passage. So there are 3 pieces I want you to include in this. So what I want you to do is I want you to tell me sorry, my computer's being weird. I want you to tell me what are global winds. I want you to tell me what do wind patterns affect. And I want you to talk to me about the jet stream, right? So this is what I want you guys to do today. Change this to white so you guys can see it a little bit better. it didn't work. You can still see it in purple, right? For your assessment for the day. I hope you guys are having a good day. I'm sorry that this was a little scatterbrained. Miss Wolf is dealing with a migraine. I'm hoping it gets better before class. But yeah, we will go from there. And I will talk to you more on Wednesday. Bye, guys.